Let's get started. Let's see your questions. Johnny gets paid $15 just accepting a job. He earned $5 for every hour spent mowing and weeding the yard. What is the function rule that models this situation? Alright, good job. When they ask for function rules, they ask for explicit formula, and you have provided explicit formula. But you are only the rule should include y equal to your function, the expression part of your function, instead of just the expression itself. Okay, so we're gonna look at. So today, because last time when we met on Thursday, I reviewed the prerequisite skills. However, this topic has a lot of content. It's kind of very broad. It covers some of the skills that you have learned in other courses. However, still in general, I think it's very broad. But today I have some content that I can go over if you still don't understand. Oh, and I also have questions that is in my PowerPoint. This is a picture of me and my family visiting the Upside Down Museum. My oldest son insisted he really wanted to go into the toilet bowl, so we let him. Yeah. Have you visited Upside Down Museum before? I think Florida, Orlando has one where the buildings look upside down from the road. If I go to Orlando next time, I will visit that place. This place that I visited is in Malaysia when I visit my home families at home. Okay, so for those who are watching this recording, and I'm sure you attended my office hour last time, so you already know what I went over. However, for those who are watching the recording, if you haven't done so, please make sure you review the explicit and recursive formula and the office hour is posted under news items. Just a quick review for Reese. We want to know what is the univariate data and what is the bivariate data. Okay, so this part has some information that related to univariate data and some is for bivariate data. Okay, can you use the color that you like? Let me see. Enable drawing. Your color red. Let's pick data information that related to bivariate data. Just put a check next to the item. There are more than one. Do you need review for what is univariate and bivariate? I think I did. Did I not? Oh, can you draw now? Oh, good. Um, there are more bivariate, but and one of the things that you pick is not is a univariate. Let's see. But you got that data that includes two variables compared to one another. That's good. Okay, so let me pick my color. So this is good, right? And your average in science compared to your average in sleep hour. Average in science is one data, right? And average sleep hour is another number of data. So it's bivariate, so it's two. However, this one, your average in math, science, social study, and English, we're talking about one, just your average in that. So that is not a bivariate data. It's a univariate. We will calculate mode, median, mean for the univariate data. For bivariate data, these are data that usually graphed using scatter plot. Okay. Uh, so involve one variable. That's it. So instead of, so do you get that? Hang on. Hi, sorry. It was a student calling about office hour stuff. All right, good. Let's move on to the next one. Recursive arithmetic models. We did this just now. Okay. This is a recursive. Okay. Just now we wrote the function rules. Hold on. This is a different question. Let's try this one. Corey is working at a Best Device store. He earns $50 per day and an additional $10 in commission for every computer he sells. What is the recursive equations that model this situation? All right, welcome, DJ. So first we need to know what is the base earning, and the base earning will be your A sub 0, which is your initial number. And how would he earn more? He will earn more by additional $10 in commission for every computer he sells, okay? $10. So you start with $50, and then if you sell one computer, you will be getting $60. If you sell two, it will be $70, and so on, okay? So when you write recursive model, make sure you write A sub n. That is how you complete the whole model, the whole equation, okay? And then to represent the number before, you write A sub n minus 1, which is meaning just the number before the current number that you're talking about. Because sub n represent the numbers of space terms in that sequence. And to get to the next sequence, you plus 10. Add 10 because in this situation, he get additional $10 for every computer he sells. So the n in this case represent the number of computer that he sells. Okay? N represent the number of computer he sells. Okay. So do you think we're good with this module, recursive module, Reese? Always state the first term, the initial term. Always. If you're missing the initial terms, your module is not complete because I don't know when do I start adding $10 if I only looking at this module answers, right? So I need to know when do I start and how much do I add each time. And this is how I write. Any questions on this one? Okay, good. So which of the following is a function rule for the given recursive equation? So this is a recursive rule that we were looking at. So I want to know in this part right here, what function rule 1, 2, or 3, which one is the function rule that matched the recursive formula that we just did. Okay, this is our table. If Cody sells 0 computer, he will get $50. He sells 1 computer, he'll get $60. 2 computers, $70. 3 computers, $80. So which of these is the function rules that matches this recursive formula? DJ, you can try to draw this time. Okay. First, if you're only given the recursive rule, you need to know. I saw your selection, Reese. Let's see what DJ selected. You need to find out how the sequences. Okay. Write down the numbers, and then you will see. Okay, pick your function rule and plug in the n in it. Okay. If I plug in 0, I'm supposed to get 50. So Reese pick the second one. So the second one, let's type it up. The second one, when I plug in 0, y equal to 10 times 0 plus 50. Okay, I get 50 because 0 times 10 is 0. Then I need to check for the next one. Plus 1 plus times 1 plus 50. 10 times 1 is 10 plus 50 is 60. That looks good. I think this is gonna be the answer. Looks like. Can you see what I type? 10 times 2 is 20 plus 50 is 70. Okay. So the second one is the correct answer. Okay, this y equal to 10x plus 50 is the correct answer. Good job. This is how you check. You plug it in a number and to see which one. So why is the first one incorrect, DJ? Look, 50 times 0 is 0, right? So you only get $10 when you sell 0 computer, which is not what we're talking about. You can see the red color. Reese, can you see what I'm typing on the side? On the right hand side here, where my arrow is pointing? You cannot see the on where my arrow is pointing, the red color, DJ? You can or you can't? No, I am confused. Oh, okay, good. Sometimes if your internet is slower, it just take a while to get it over. Okay. All right. Now we just so we have a few more questions that deal with functions rules, but also I have other questions that I want to go over. So I'll leave this with you. I give you the leave this question with you. Like usual, you can download this PowerPoint at the bottom part. Today is June 27th, so find the June 27 one and you can download that. Okay, so we're gonna move on to different kind of questions. Do you think it's okay? I'm just gonna give you the answer. Okay. This is function rule. We did this in the warm up, so we're gonna go to the next one. Recursive rule for this function. Get a sub n equal to a sub n minus 1 plus 5, where a sub 0 is equal to 15. Okay, this is the recursive rules. All right. How do you use recursive rule to write certain terms? Okay, I'm just gonna do one, and I hope you guys know it. So you try. Let's try A. Make sure you know this. We're just gonna do one here. You try A. Well, I'm also doing it. So it say this is my recursive formula. Okay, Tn equal to 2.5 Tn minus 1, meaning I use the previous number and multiply 2.1 to get to the next number. Okay, so if my first number is 6, to get to the next number, I will multiply by 2.5. That's what it means. To get to the next number. And I multiply 2.5 each time to get to the next number. And the first number is t sub 1. Second number is t sub 2. Third number is t sub 3. Fourth number is t sub 4. And then you keep going, you get to the sixth number. Okay, so to get to the t sub 4, you just do 6 times 2.5 and then times 2.5 and times 2.5 again, okay? Thank you. You should get 93.75. Okay? Yeah, you that's right. So you keep doing it 2 more times to get a T6, okay? I think you get 5, if you get it right, 85.94. All right? Are we good with this question? We're gonna move on. We have a lot more to work on today. All right, writing recursive formula for exponential module. Okay, I realize this question is the one of the top question a student missed. So I think I should go over this. And how do you feel like if do you want me to? I would just talk about this, okay? Just to prevent any future careless mistake. All right. When you see the test, they're not going to talk about ladybugs. They talk about something else, okay? But they also will talk about population. They also will have a growing rate or decaying rate. And those are the similar things that you should take note. Okay? A population of ladybugs started at 10 ladybugs. So that's my starting point. And is growing at a daily rate of 3%. Meaning from wherever they are, they plus 3 more percent, right? Write a recursive equation to model the population of ladybug on a given day. I want recursive equation. So first I need to know what's my starting points. In this case, my starting point is a sub 0. How many ladybugs do I start with? 10. Okay, read from context. Okay, thank you. Because the ladybugs are growing, the rate will be more than 1. Okay, R is more than 1. So every additional day, there is additional 3%. If I change percent to number, I get 0.03. So the rate is whatever they start with, which is the 1 here, plus the 3% that's added every day. Okay, so this is the existing one, and this is the additional one. So the general formula, this is a generic formula for, you should write this down, for any exponential recursive, there will be this general formula. Where this number right here, an means whatever whatever days that you're calculating in this case, because they're talking about daily rate, and a sub n minus 1 means the number from the day before, okay, from the day before, times the growing, times the rate, and the rate has to be our existing rate plus the 3%. Okay, this is the tricky part, not just 3%. If you time just 3%, then they are actually shrinking because you're talking about whatever you had previously and it's only 3% left, but which is not. We are additional 3%. So you need to have 1.03 as R instead of just 0.03. This is a common mistake here, okay? And then what is your initial population, which is 10? So given this formula and given all the information, can you you can type. Can you type? Oh, you can write your answer. It's kind of hard actually. This board is hard to write. Let's see what I have for you. So let's just get going. Here's the answer, okay? The black part is the answer because it's hard to write. So a and a sub n, you plug in a 1.03 and then a sub 0 is 10. Now this whole part is a recursive formula. You cannot left out the a sub 0. If you left out the a sub 0, it's incomplete because we don't know when does it start, okay? So here's the extension. What will be the population of ladybugs after the week? If you are asked these questions, right? Given this recursive formula, you will just, you can do it in a just very simple way. You do 10, start with 10. The second day, you times 1.03 multiply 1.03 to get to the next day, and then you keep doing it for first, second day, third, fourth, fifth, sixth, and seventh. You keep doing it for this many times, 2, 3, 4, 5, 6 times. Then you will get the population of the ladybugs after a week. Okay? We're gonna move on, okay? So, now, the next part of this topic, talking about the bounce ball activity. Remember the homework that you submitted? If you think you guys are good with bounce ball, I will just skip this part because this part also was recorded where I told you all to watch. I put a link. However, if you still need further explanation, I will explain it here. So can you please let me know, tell me either to go, because going over it would take all our time. Not go, this was already the bounce ball activity, sorry, what happened? This was already recorded. Okay, so if you want me to skip this part, just say skip. Okay, Reese says skip. Oh, DJ says skip. Reese is not here anymore. Alright, DJ, let's move on because it's recorded. And then after you watch recording, you still don't understand, you can ask me, okay? Alright, let's work on this question. So given this function, okay, what sequence will this function create? Meaning, if you plug in x as 1, so plug in when x is 1, okay, what is your y? Y equal to, so calculate. This means 3 to the first power and then times 9. It's not 3, it's some other number. So when x equal to 2, you need to do when x equal to 3, and x equal to 4, and also do when x equal to 0. This is very simple, but if you don't know your order of operation correctly, you will get it wrong. So, DJ, I want you to do your calculation, okay? 3 to the 0 power, then times 9. Use your calculator, do 3 to the 0 power, and then times 9. Thank you, it's 9. Anything to the 0 power is 1, okay? Now 3 to the first power times 9. This part of my handwriting is very hard to write on this board. The pen acts slower. 3 to the first power times 9. You shouldn't get decimal number. Something is wrong. Just do 3 times 9. Yes. Right. Anything to the first power is original number, which is 3 times 9 is 27. Okay. This, if you don't have a calculator, you should also be able to do it. Always do the exponent first. 3 to the second power times 9. Now you try. None of this number will get you a decimal number. Okay. Okay, next one. 3 to the third power. We are doing the next one. 3 to the third power. You do 3 little head and then third power times 9. 3 to the third powers. Uh-uh. Let me see. You have Now you need to have a calculator. You need to know how to use it right. What are you gonna do if you didn't use it right and then you're in a test? You cannot go to online calculator. You need to have a calculator that work right, and you need to know how to use it. Okay, this kind of thing I can. It's kind of hard to help. You need to go search a manual if you don't know how to use it and learn it. 3 to the third power times 9, you should get 7. Right, 243. Okay, then 3 to the fourth power, you're right, times 9 was 720. Sorry, DJ, you're right. Okay, so this is the number that you're supposed to get. Your choices will have different number together. This number will be written as a sequence. Okay, like that. Sequence like that. Okay, not a dot, it's a comma. Comma. All right, let's see the next questions. This is the same recursive formula kind of questions, similar to our the what was that thing? Ladybug's questions. Okay. So you can see here. Here's the initial value is 3 because it has bacteria 3 square milliliters. 50% increase, meaning from wherever it started with plus a 50%, equal to 150. Yeah, that was a 150, not 120. And then you change it to a regular number, you should get 1.5. So your function rules is y equal to 3 times 1.5 to the power of x. 3 is the initial value. This is similar to our explicit formula, okay? If you forgot how to do this, refer to the Welcome back, Reese. Is your internet dropping? Any question on this? Oh, okay. So for linear function, the rate of change is constant. Okay. For exponential growth function, the rate of change is increasing. Exponential decay function, the rate of change is decreasing. So some of you have a misunderstanding that, oh, if it's exponential function, the rate of change is increasing. And some of you might not, really understood it very well. So the discussion post, I make some correction and also added some information for students who I see still haven't gotten an idea. So if you have that response, please look at that discussion post. So now we are going to look at periodic function. Okay. The periodic functions are functions that are going up and down, back and forth at the same tool spot. Okay. Sine, cosine, and tangents. Sine and cosines are the most common periodic functions. And here are the three trigonometric ratios that some of you might have seen it before, some of you might have not or forgot. But today we are going to look at cosine function here. Trigonometric ratio is a ratio that measure the three sides of a right triangle. Okay, it's always has a reference angle. Okay, the reference angle is always never be the 90-degree angle. It's either the one down here or the one up here. Okay, and the one opposite the side opposite the 90-degree is the hypotenuse. The side opposite the angle that we're looking at here, the ones opposite it is always the opposite side. Okay, can you see they are opposite each other? And the one next to the angle itself is we call adjacent side. These are very basic idea that you need to know when I move on to the next part of the lesson. Questions on this after I explained it? Have you all seen trigonometry ratios before? Or this is brand new to you? Okay, how about Reese? Oh, Reese is not here anymore. Well, if this is brand new to you, we will have a long lesson, but I only have 20 minutes. Let's see. I probably will send you some video to review, okay, DJ? Because for most students, they already seen some of the basic of this, and you probably seen some. You might forgot, okay? Because this thing itself is take a whole day of lesson. But what you need to pay attention for the next part of the lesson that you understand is cosine function. Cosine is just a ratio. Cosine theta, cosine of an angle is just a ratio. A ratio means what is the number that when adjacent side, which is how long is this side, adjacent side, divided by hypotenuse, divided by how long is this side. When you divide these two numbers together, you get a number, right? You get a number. And that number is a cosine ratio, cosine of this angle right here. And these numbers are, that can tell you how big is this angle, meaning how far apart is hypotenuse from adjacent. This angle can change. It could be larger or smaller. And cosine of the angle tell you is a ratio of adjacent divided by hypotenuse. The length of adjacent and the length of a hypotenuse will change the will change the degree of this angle. Okay, so this is the relationship of the angle and the side next to it. This is, we're talking about cosine. Okay, you need to know that. Now, the next part of the lesson, I will be explaining Ferris wheel. Have you looked at this content, Ferris wheel, in the course? DJ? Have you looked at the Ferris wheel content in the course? Okay. I have also posted the explanation of this Ferris wheel explanation from my previous semester teaching for students who might need it first. I put it under the news. Do you want me to go over this content, or you think you got it? You got it? It's okay if you need. Okay. Now, I can spend like 5 minutes talk over this real quick. However, I I will spend a few minutes to talk about it. Okay. But I need to go get some water. Okay. So look at this. This is I took this content from the course, and I kind of break it down, and I put it in different pages, and I add additional thing to try to explain it clearer to the students. The content here is the same content from the course, except I just intend to break it down more. Let's see. On February 11, 2008, Singapore opened a new observation wheel called the Singapore Flyer. Okay, at the time of its opening, the giant Ferris wheel was the tallest in the world. The Singapore Flyer consists of an observation wheel with a diameter of 150 meters atop a boarding board. Okay. Overall height of 165 meters. So this Ferris wheel here from here is 150 meters from here to here. And then the boarding board itself is 15 meters. 15 is very tall. 150 meters is so tall when you do it vertically. So overall, the whole structure is 165 meters. 28 air-conditioned capsules, so there are 28 of them, rotate on the outside of a wheel to provide unobstructed views of the city. The wheels rotate at a constant rate of 26 centimeters per second. This is slow enough that the wheel does not need to stop for loading and unloading. There are special passengers, unless there are special passengers needs. Describe how They will calculate the capsule height above the ground, draw and label your diagram in an accurate diagram of the wheel showing the dimensions given above. Use a compass or other tools to accurately draw the circle. Well, we'll see. So, solve these problems. So this is our problem. At the time 0, the capsule is in the boarding terminal. How high above the ground is the capsule at this time? Okay, at time 0, right? This capsule right here is at the boarding board. This is the boarding board, boarding terminal. How high above the ground is the capsule at this time? So we know the boarding board is 15 meters. The height of the boarding board, if you don't know the boarding board is 15 meters, but you know the total structure is 165 meters, subtract the diameter of the Ferris wheel, you will know the boarding board is 15. Okay? After 1 minute, how far has the capsule traveled around the circumference of the wheels? So we need to know how far does it travel around the circumference. Meaning, if you load it here, after 1 minute, it's traveled in a circle, right? Along the circumference of the circle. You can see the center of the circle right here. We need to know how far has the capsule traveled after 1 minute. So to answer that question, since the wheel rotates, since the wheel rotates at a constant rate of 26 centimeters per second, so every second it moves 26 centimeters along the circumference. And there are 60 seconds in a minute. So twenty-six centimeters per second times 60 seconds for every minute, because I want to know after 1 minute, right? So 1 minute, so I multiply it by 1 minute right here. After 1 minute, I have traveled 15.6 meters. Or if I want to write in centimeter, it's 1560 centimeters. Questions on this one? Okay. So Ferris wheel question 3. What is the height of the capsules? Look. So let's say after 1 minute, right, the capsule had traveled 15, look at my arrow. The capsule had traveled 15.6 meters around the circumference. But I need to know how high exactly it is from the ground. What is the height of the capsule from the ground after a given time in minutes? What is 165? 165 meters from the ground after 1 minute? Do you have microphone? You can talk if you want to. No, this is 165. You see my arrow, my green arrow? This is 165. It cannot be 195. It cannot be floating in the air. What is the unit? Meter or centimeter? Inches? You can talk if you want to. I give you permission to talk. So, it is not 165. I don't know. It is somewhere in between below 165 because this whole structure is only 165 meters. Okay? So I need to calculate how far is it. Let's say it has traveled up here, right? Let's say it's traveled up here after a minute. I want to know how tall exactly it is from the ground.
Can you hear
Okay?
me?
So the calculation is not as simple. Yes.
You need to have a headset.
Yeah.
Otherwise, I hear myself.
You need to
You
have
said what?
a headset though.
Do you have a headset?
Otherwise I hear myself.
Yes, one sec.
Do you have a headset? Like